Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about seaweed biofuel versus magical bullshit. So let's dive deep into it. Now, exactly why do we need to go into seaweed biofuel and why no other things can even work, even remotely? Let's dive deeper into that. Well, reality is our portable power demand is too goddamn high. Portable meaning it's not connected to anything. For example, if it's a train and there is no overhead line, if it's a ship, if it's an aircraft, things of those nature. Bulldozers, crane, whatever have you, and it's huge. How huge? Well, we use multiple fuels to take care of multiple scope of it, as in petrol for light puppies, diesel for heavyweight puppy, kerosene for fast puppies, lpgs for power plants, and heavy fuel oil for some big lumbering giants on seas. So you can understand that like a lot of energy is consumed in chemical form so we can meet our portable energy requirement. And generally, roughly, because again depending on where you're getting your crude oil from, what sources is like the ratio changes, but roughly it's around 80% of barrel of crude oil is generally converted for energy. There are some for other stuff like plastic products and grease, mobile and all that jazz, but 80% roughly is for energy. How much is that chemically speaking? That puppy translates to 1.2 megawatt hour. That's a lot of energy, like a lot of energy. And how much do we drink per day? 2024, again, year has over, so 2024 was averaging 103 million barrels per day. Oh, and I've seen one person commenting that, oh, we are not actually using it, we are just storing it. No, we are burning it, okay? There is no storage that can store this sort of thing. At best, country can store enough for a few days. At best, not even a month. So, and not to mention our CO2 output is matching that we are actually burning it. So 103 million barrels 2024, that's the data. Now assuming 30% conversion efficient, now you're like, no, that's too high or too low. Well, here's the deal. All of these things have different scale. Like the best efficiency I know is from heavy fuel oil. Why? Because those huge engines, they exceed 50%, meaning they start, like if you're buying a container ship today, it will have an engine, let's say a man diesel engine or something like that. It will start at 50% thermodynamic efficiency. Their BSFC could almost reach 150, 140 to 150 kind of BSFC, that G per BFC, per 1 unit of energy. So it's very efficient. LPGs, again, power plant, especially if it has a multiple thermal energy recovery system or power and heat system, combined heat and power, that could be 60%. Kerosene generally used in jet engines, they are also very efficient nowadays. And diesel, again, very efficient puppies. Petrol is the least efficient one. Diesels, like you can easily compare it, like buy a petrol engine, best BFC you're gonna get is like around 230 to 250 grams of fuel burned for 1 unit of electricity. Diesel, let's say you look into Scania, they actually give the data. So Scania will give you like a 180 for a diesel system. So, and that's why I said HFO is one of the best, like it touches 140 to 150. So that's there. So we are getting bonkers amount of energy, portable energy, and that translates to 37,000 gigawatt hour per day. And if you like divide by 24, that gives you 1.5 terawatt. It's huge amount of energy, like bonkersly huge. And you're like, okay, how much energy does our grid make? Well, it's irrelevant, because again, if you're using these itself to make energy, what's the point? So 30 to 40% of our grid is only renewable. So yeah, right now, if you think that we can replace all of this with just electricity, yeah, no. Yes, Europe has reduced their coal power plant. Why? Because they are consuming gas. It's not that they have actually solved the problem. So, and there is another aspect of it. I keep saying always pay attention to the top population countries, as in like top 10 population. Because here's the deal. If you're looking at a tiny European nation, you have a very bad scaling problem. Like very bad scaling problem. Like think about this, like rat gets cancer. Elephant getting a cancer, its cancer gets cancer. Not even joking, that's why they live so long. Like that's such a weird thing, is like its cancer growth is so huge, it itself has cancer growth. It's a weird thing. Like, but again, it's a biological scaling thing. For example, if you are talking about China, the kilometer surface area is so huge that they have a, let's say, 3 gorgeous dam. That is bonkers. Let's say 12 gigawatt of power output, GG. Where is the population center? It is so far out, they had to build world's longest distance, high power, basically HVDC links, around a 1200 kilovolt at give or take 12 gigawatt of power. The kilometer, basically the line, that will jump multiple countries in Europe. So let that be very clear. Do not compare tiny nations to large nations. And there are also another aspect is like, oh, you are buying electric car. Where is it being made? Oh, it's being made in somewhere else. Or where is being mined? Oh, it's somewhere in Africa. So that is the reason why I always say, look at the oil consumption. Do not look at a small nation because it will give you a warped perspective. And you have to fix the whole planet. Failure to do so, you die anyway. You're like, okay, in our country, everything is clean. Yes, you are still breathing the same air. You can reduce local pollutants, but like we have winds, tsunami, typhoon, hurricane, good luck. So that's why always pay attention to the global scale. It makes everything clear. So grid wise, we are not there. Like I'm being very optimistic saying 30 to 40%. And seaweed is the only thing that can handle this heavy load. Nothing else can do that. And it will become clear as I compare it to all other magical bullshit that people want to believe. And why we can do with seaweed, not with something as well. Seaweed only gives you, requires two things. Sea, we have more than enough. Again, I'm not talking about Bhutan or Nepal. They don't have sea access, but top 10 countries in terms of population, all of them have sea border. So you need sea, we got this. You need sun. Sun is tax-free, we got this. What is the output? Direct chemical fuel. Basically, it's taking solar energy, giving you crude oil directly. There is no conversion loss. And again, we started basically long-term data analysis from like, let's say 90s. And that time we were averaging around 360 ppms of CO2 in atmosphere. At this point in time, we are almost crossing 430. And you can check this, verify this from all satellites, all instruments, almost everything. Like you can check it, go YOLO on it. Everywhere, but you do have to have multiple sources because if let's say you are in some place too that had wildfire, it will have a ludicrously high number. So you have to have multiple data sources, as in like multiple sensors or satellites. One satellite can again orbit and scan large enough area to give you real world data, but output is same. It's going high enough, and if it starts to reach 800 or 1000, we did. So fundamentally, and why it's happening, because we are offsetting the carbon. As in, instead of making the hydrocarbon that we need to consume, we are mining it from the ground, which should never happen. Like Earth biosphere has already sequestered it. We are pulling out the poop. And if you look into any organic, specifically algae or seaweed, what is made out of? Hydrocarbon, lipid. And if you look at the lipid, like actual chemistry, it's ludicrously close to crude oil. Look at all the other things, cellulose and all that. It's what it is. It's hydrocarbon. Now, again, here you have a lot of oxygen, hydrogen, but again, this has generally a lot of carbon. And again, how the heck plants come to reality? How the heck trees come to reality? They consume things and use energy. Where the matter is coming from? Matter is coming from water. Basically, it's eating hydrogen from the water, and basically carbon from carbon dioxide. It's eating oxygen from there. And basically, it's double eating oxygens and taking hydrogen and carbon. And that's how it's building a lot of things. Like most of the things in plant is literally built by this hydrocarbon. So all you have to do is seaweed. Why? It has surface area and solar energy to actually give you the fuel, and it will be carbon neutral. Basically, this number will get stuck at a point, and this can finally go down. So let that be very clear. Do not pay attention to, oh, this tiny. Look at the global fuel consumption. It's like, oh, this nation is like, oh, dude, where the heck all the software services are being run from? Oh, half of the data center is here, half of the data center is there, half of the service center is here. And oh, it's like where the product, oh, it's in Vietnam, and this is like, trust me, look at the planet as a whole ecosystem, only then it makes sense. So this is a genuine problem. Like we consume a bonkers amount of this. Petrol, diesel, kerosene, LPG, heavy fuel oil, bonkers amount of it. Oh, and I'm not counting natural gas. Not even counting that. So electric vehicles, right? This is the first magical delusion that people have. Yes, EV is not ready for prime time. As of now, if you think in 2025 that electric vehicles are ready to go, no. Just no. And grid is nowhere near. Let's just assume you build something magical. Let's just assume I give you magical technology. Let's say I give you quantum capacitors that has let's just say 75 unit capacity in 1 liter, 75 kilowatt hour in 1 liter. Assuming it does not go kaboom, that should solve your problem, right? Infinite range and all that jazz. No, you still don't have the energy. That's why I specify. I really like Dr. Rajendra Sharma's discussion about this. Like, it does not matter the battery. It's like for a battery to discharge, you have to charge it first. Where is that energy coming from? So grid is not ready. That's why I specified. Like the amount of gigawatt hour we are burning per day, if you compare it to large countries, you just can't. Just can't. Like flat out grid will collapse. Flat out. That's why I said, like, especially, they are able to switch because they are switching only petrol-based systems. And heavy things, they don't have it. It's somewhere in like, Kenya, in Africa, South Africa, those sort of things. So, or China, or Vietnam, or India, or America. So fundamentally, you really have to scale the whole planet's grid against whole planet's requirement. And then it's like, yeah, grid just cannot do that. Top 10 countries in terms of population, in terms of energy consumption, nope. It just, nope. You cannot do that. And without subsidy, basically, if I remove subsidy, nobody will even talk about electric vehicles. It's just unaffordable. And you can easily see that, like when Tesla was originally being manufactured, the battery was very conservative. It was like, 33 unit hour battery. Now we have like 60, 70, 100, or like people are trying, how the heck that's happening? Subsidies. And again, that is true worldwide. For example, India, like everybody is like, okay, petrol is so expensive. It's not expensive. It's being expensified because they are taxing too much of it. They are taxing oil too much, because again, we're supposed to get cheap oil. Oil is very cheap right now, but like, why the heck tax is high on that? We are getting like flat price. Like our oil price has been same, I would say, for 4 or 5 years. Why is that? Well, they are taxing. They are spending 10,000 crore. That's a bonkers amount. That's like billions of dollar, not billion, billions of dollar. I hope the conversion is wrong, because that number is too stupid. And that's just in 3 years. That's Indian government. And that's just the central government. Other state governments also have smaller systems. And you combine all of that. If I remove that money tomorrow, like no subsidies, nobody will touch electric vehicles. I never understood how the heck India's jump into electric vehicles have stupid batteries, like 75 unit hour battery. I'm like, that's too big. That's too big. That, like, you literally have battery on wheels. That's too big. Oh, they have a subsidy. Basically, more kilowatt hour battery you have, the more subsidy you get. That makes sense. And you're like, okay, but China is doing it. No, they are also burning so much money. They have increased inflation. And their project name is New Energy Vehicles, NEV. And now they are slowly starting to, tone it down. The first thing every company does, okay, now switch to hybrids. You cannot, like, it's not ready. We spent a century to fine-tune a normal commercial vehicle. Electric is nowhere near. Again, if we had time to jump to like properly to series hybrid, like as in range extender, basically full electric system, battery is small and combustion engine is the main generator, we could have sorted out everything. We haven't properly sorted out everything. We are just brute forcing governmental numbers into it. So that's why it gives us a wrong illusion where it's like, oh, electric vehicles are cheap. No, it's not. If I remove subsidy, you would be shocked. And again, let that be very clear. Every major country. So, and again, it's not actually helping. If you did series hybrid, it will actually reduce fuel consumption. That will directly give you enough money. And not to mention, it will give you time. It will give you efficiency. Petrol, you can almost eliminate by 80% of population. Most people, oh, we need 700 kilometer range. No, you don't. You're not going to wake up, okay, I'm going to take my son to like, 500 kilometers away from me. No, that's not how it happens. 80% of people barely drive 80 to 100 kilometers a day. Only give that much range. You charge every night. And again, slow charge, AC single phase or AC multi-phase. Multi-phase because the USA has like weird 2-phase. India has AC single phase or 3-phase. So those sort of simple things, nothing fancy, no super fast DC fast charging, simple, cost effective, logical, doable. And if you forget, no problem, you have a fuel, go. And what if you have to do very long range? Go. And if you're like, okay, what if I'm doing sightseeing? Then people can easily say, hey, this petrol pump, you can even charge your battery, man. Like, that can be done. And then slowly over time, you will grow up the electric system. And again, cost would be low. Why? Because your engine, instead of having a like very giant power band, it would be a generator. Very specific, very lightweight, no variable valve timing, no gearbox, simple. It can be done. Like Toyota and Hyundai almost achieved this in 1998 and 1993. But again, they were trying way too early. They were using nickel-cadmium batteries. With lithium-ion, they should have been able to do this by 2010. But because people who got like Elon weed, we jumped into this. And government started funding it. So it always gave us a wrong illusion. It's like, oh, electric is doable. No, it's not. The moment I remove governmental subsidies in all these major countries, kaput. There won't be electric. Like bonkers. Even in USA, like Ford is making electric vehicles and the power plant is like $1 billion in subsidies. Millions of dollars. Of course, there's a lot of corruption, there's a lot of red tape, but it is reality of it. So fundamentally, and all of this is just trying to replace petrol. They are not even trying to touch a diesel. It just cannot happen. Maybe you can push for diesel buses, but good luck trying to do anything like heavy vocational truck. That's not happening. Bulldozers, not happening. Even though ironic part, we always had diesel electric bulldozers. Long ago, we had it, like 1960s we had it. So that's the reality of it. Nobody's even trying it. And I have no idea how the heck people have such a bad understanding of energy. It's like, oh, Volvo releases a truck in India for like, container ships. It's like, cool, awesome, GG. How much is the battery? 800 units. 800 unit. You need a transformer of this size, and these sort of transformers, they do not run on 11 kV or 33 kV. They need 135 kV, and these are made to order. And they're like, oh, we're gonna have like a 3 megawatt charger plug. Yeah, this is the charger plug for trucks and heavy loads. 3 megawatt is not something that you can just like lol. The transformer will be more expensive than Ferrari. And again, whereas you are getting the energy for. So let that be very clear. Mathematically, scientifically, we can't jump to EV as of now. And again, EV is not fully cooked. It needs a lot of time. Only now I'm seeing one battery topology, which is a blade battery from basically BYD, which actually has packing efficiency. Now they are reaching packing efficiency. Although you can say the big cell of Tesla finally starting to reach good packing efficiency. Like chemistry-wise, we should be energy-wise here. This is where we were in like, let's say 2015. This is where we are now. So fundamentally, we are not even touching that. You cannot touch diesel things. So that is it. And battery does not get lighter as you use that. That's why you can't do this with planes. Short range planes, you can do that. Training aircraft, GG, awesome. But like a long range jumbo jet, like I was on a jet, Airbus A320 or something like this, Indigo. And it was like, Captain announced it. It was new to me. Not like, I have flown in planes. Most of the time they don't announce it. You're saying, yeah, we are flying at like, average speed of 800 km per hour. I'm like, damn. Then I googled it. It's like, oh, wait a minute. This plane can actually go to 900 cruising speed, not excess speed, cruising speed. They're driving slow. So that's the reality of it. You cannot have a plane doing that sort of performance at that sort of range if the battery is not getting lighter. Law of physics. And again, we know the upper limit of chemistry. Like same way E equal to mc square limits how much energy you can get even with a matter-antimatter reaction. Same happens in chemistry. We had known from day one how much energy you can get from lithium ion chemistry. Why? Because every person in lab, that's the first thing they did. Oh, lithium? Every possible alloy, everything in periodic table has been tried. Every single thing. We tried with, let's say, lithium, cobalt, manganese. Let's say those categories, heavy properties, we started with those. Why? They were the highest energy. Everything else we did is only going below from that. So we had that. Then we were like, okay, this catches fire too much. Lithium iron phosphate. Okay, safer, but like, okay. Lithium titanium oxide, much safer, much longer lasting, but again, energy even low. Now we're like, okay, we're going to go to sodium, even lower power. So trust me, if you want to believe the magical bullshit was like, battery is going to be better, battery is not going to be better because battery chemistry became better. It's just packing became better. Meaning how much kilowatt hour you can have in 1 liter volume actually started to approach the theoretical maximum. Like theoretical maximum is here, we are reaching. But this number will not go up. Like same way E equal to mc square locked, we know what every element in periodic table can do. Of course, I can easily expect a battery to last longer, handle much more charge cycle, discharge cycle, much better temperature. Those things I can easily see. But like it's going to have more oomph. You may not want that. You may not want that. Like same way, we could have a boiler, steam boiler that is like super ludicrously high powerful. People stopped wanting it. Why? Because it went kaboom. So same thing happens with battery system. Let's say even I give you a quantum capacitor, there's a very serious risk it can go kaboom. So fundamentally, reality is EV is not there. At best, you can drive petrol. Realistically, if you try to touch replace diesel, you're going to kaput the whole grid. Whole grid, you're just going to kaput it. So, I'm just like, oh, we just have a 3 megawatt plug. Like 3 megawatt is not something that you can just like, lull. So that's not happening. And again, subsidies are bonkers. Go YOLO on it. Like do your own research and you will be shocked how much money subsidies are doing. Like it's like you are taxing that fuel, hoping that we buy fuel so you can subsidize or basically electric, which means basically giving money to China. I'm like, what's the point in this? Now we come to another brain damage, that is hydrogen and ammonia for some reason. And here's the deal. We have been smoking hydrogen for 1807. This is the early prototypes of hydrogen combustion engine that we built. Yes, it is older and this number is 18. We started combustion engines, fuel combustion engine by 19. This is 18. We have more than enough experience. So why the heck it did not catch on? We used it in Apollo, the flagship mission of human civilization. We used that. Space shuttle, we used that. Then why the heck we abandoned all of it? If we have been doing it for so long, we did such a flagship system where money was no object. Why did we abandon it? Because law of physics, same way E equal to mc square is fixed. Law of physics is fixed. It says that even liquid hydrogen can only give you 8 megajoule per liter. That is not enough. To give you a contrast, compare that number to diesel or even petrol. Both are above 30. You can't compare that. And you're like, okay, but engine are inefficient. First, you are assuming you're going to get 100% out of diesel, 100% out of hydrogen, and compared to basically petrol and diesel, 30% exceeds this. Like, you have to get more than 100% out from hydrogen in order to compete. That's today. It cannot be done. We've been this, like we've been there. And this is law of physics level. It cannot be, oh, we're going to have modern technology, we're going to have do this and we're going to have that. No, it cannot change. And round trip efficient, meaning what if you want to use it as a battery, energy carrier? Because again, if hydrogen was something that we drill, we get hydrogen, GG, awesome, no problem. But if you're drilling and you're getting methane and then you are steam reforming it so you can send hydrogen to places, what are you smoking? Just use the methane directly. So fundamentally, that's, if we were getting hydrogen basically wells, GG, enjoy. We are not. So that's why we have to understand this, like it does not have enough energy. And when you're talking about making it, like, making it from water or solar energy and all that, round trip efficiency is 40%. And again, let that be clear, that is way too optimum. That is like, ooh, optimum. So if I give 100 unit of renewable energy, your wheels will only get 40 of it. If I give 100 unit of electrical energy to your electric vehicle, you're going to get 87. This is law of physics. It will not change. And again, be mindful. I have seen like a lot of new generation electric vehicles, they are almost exceeding that, where they are like almost touching 90%. That's like normal. I'm not talking flagship, best of the best. Like that's achieving hydrogen. And again, that's why Toyota Myra and like hundreds of cars that has been running on hydrogen for, I don't even know, 1990s, all of them failed for this exact reason. You have to burn 2x the energy to compete with the same thing. Energy is never free, nor it could ever become a free. So this whole people are like, oh, you can recharge in like 1 minute and like just okay, cool, awesome. Where is that hydrogen coming from? Oh, you're burning grid. Literally, oh, we're gonna have solar. It's like, is solar free? You have to get land for it. You have to get inverters for it. You have to get solar panels for it. Why get 2x more when you can get the job done on less? So fundamentally, this is law of physics. And thankfully, I have to say, I have seen at least pilots talking about it like, bro, hydrogen cannot fly jumbo jets. We've been there, done that. Soviet Union did it. America tried to do it. America built fighter jets. Soviet Union built jumbo jets. Every Tom, Dick, Harry tried it. And we learned it the long way. It does not work. The galvanic density is just not there. And I'm seeing shipping companies also sharing this sort of graphs to explain to people, you cannot use hydrogen. For example, LNG tanker has some boil off. They use that to drive the engine. Cool, awesome, non-thing. So let's classify as one. If you jump to ammonia, ammonia has better packing density. So that gives you almost 2x the size of tanks, meaning your tanks are now 2x, 1.9. And like, okay, what if you use hydrogen? 2.5x. At that point in time, your tanker is half fuel tank for the craft itself. It does not scale. Like it just does not scale. And that is on chemistry level. It cannot be changed. It cannot be bypassed. Fundamentally. And okay, what about ammonia? Here's the, if you are losing this much energy going from a basically electric vehicle to hydrogen, brain damage, do this again if you want to do ammonia. Why? Because ammonia has hydrogen as feedstock. Oh, how do we make ammonia right now? We use methane. We use methane to make ammonia. So fundamentally is just dumb. Like it is dumb. We have known this from 1807. Like, to be fair, we figured it out by 1900s that hydrogen does not have enough density. And by 1990s, like, yeah, people were like, what if we had like, platinum catalyst and this and all that? We used that. That was used. We learned after using it, yeah, just throw that shit away. Have solar panels. That's why Orion capsule has solar panels and batteries and done. Everybody goes home. Everybody wins. Because if they did not, they had to double the size of solar panel. So that is why hydrogen cannot work and ammonia is, like how the heck people are smoking that is beyond me. Like this is a thermodynamics issue. It cannot be bypassed. Energy cannot be bypassed. You could say, what if I use a solid metal halide as energy carrier? It's just like forgetting that for storing 1 kilogram of hydrogen, you may need 10 kilogram of metal powder. So now your fuel tank is not an empty tank. It's actually heavier than the fuel. It's like, oh, you need 10 kg of like, hydrogen. Oh yeah, it's 100 kilograms of fuel tank. It could work for submarines. I could see that. It could work for submarine. It could work for forklift. Basically things that have giant counter mass. I can see that working. But other than that, good luck. And again, at that time, might as well use battery, more efficient. might as well use it. Because again, either you're going to be effed by the thermodynamic conversion efficiency or you're going to be effed by the density issue. You're going to be effed anyway. And again, I'm not talking about economics because these are law of physics. Economics, you can brute force a subsidy and like, okay, subsidy, see people starving on the street and see how much cheaper hydrogen we have, because again, you're subsidizing it, meaning you are just taking it from here. Like rather than eating like this, you're like, that's what you're doing with subsidies. But these are law of physics. It cannot be changed. So this is hydrogen and ammonia brain damage. Now we come to land fuel, which right now is very hot topic in India. So basically you have to understand this. Ironically, our forefathers were very ahead of their time. Henry Ford and Rudolf Diesel both started with biofuel. Yes, you heard that correctly. Both of them, pioneers of their civilization, started early on. As in, ethanol was started to used in 1908, and basically, fun fact with Rudolf Diesel, diesel engine is named after him. Diesel fuel is named after, most likely after his death. So let that be very clear. It's fundamentally Rudolf Diesel made diesel engine, and to run a fuel engine, they said diesel fuel. So that, then how the heck it was running the engine? It was running on peanut oil. That's what he did on Paris World Show 1900. Yeah, old technology. That's why you can use normal vegetable oils, palm seed oil, go YOLO on oils. Most of the oils will work in diesel engine because that's how it was designed to work. Although don't do it in a normal modern car system, because again, your car engine expects way too much things in your fuel, as in like detergent, oxidizer prevention, water repellent, these sort of things. It will work, it just won't last very long. Fuel injector will be confused. It's like, why engine is behaving differently? So that's how we started. Good, right? That's carbon neutral, meaning you burn the fuel, the next crop cycle eats it, and tada, you're basically running on solar energy, and you do not have temporal displacement, meaning you're not taking poop out of the past. You're running in present. The CO2 does not go up or down. It remains exactly the same. GG, exactly what we are doing. Organic creatures. We eat crops, we burn it in our belly, and then we exhaust the CO2. Plants consume it, cycle repeats. Is just solar energy with extra steps. It works, it's efficient. However, we realized very early on, like let's just say by 1920s, basically after World War II, in World War II, we started like, yeah, we are consuming bonkers amount of it. And the reality is our demand cannot be fulfilled by anything that you grow on land. It just cannot. There was a certain illusion that people got, like especially after invention of tractors and like mass scale of tractors and all that. It's like, okay, what if we can scale it? It's like, yeah, no, you can. It's for short duration, it didn't make sense, but like, yeah, no. Because again, we have limited agricultural land, irrigatable lands, and again, those lands are for food. You need food more than you need fuel. We can survive without fuel for thousands of years. We cannot survive without food 3 months. So fundamentally speaking, we learned it the hard way that it cannot scale. And all the attempts, be it America's attempt with corn going cuckoo, being its sugarcane's attempt with Brazil, all of them have the same outcome, as in it destroys the environment. Like in case of Brazil, shift delete all the rainforests. In case of America, food prices goes up stupid. And like, it never made sense to me, like why America has expensive food. Food should be so cheap in America that it's like, bro, like we don't tax food, it's wasteful. Like that should be the case. There's so much agricultural, all of them is corn. And again, they did all the research, outcome is the same. It was creating more CO2 than it would have been. If you're directly using the fuel, it would have been better. And again, now they can't change it because they have destroyed the land. They have like everybody knows how to grow corn. It's like now you have to relearn everything, which they won't. So they're gonna die. So outcome is the same. You can try it. India is now smoking it. Is like, and again, I have deep shame that my country fell for this BS, where it's like, oh, ethanol will be made out of basically agricultural waste. It's like, if that were true, we would have been doing that for 75 years. We don't, because it does not have enough yield to justify it. Heck, even biogas, which we know it works, it requires a certain scale of investment, otherwise it does not work. Same happens with this, basically ethanol production. So environmental degradation, rising food costs, basically it's unsustainable. And Mark 1, basically the first time humanity tried to run on solar energy, solar chemical energy, was crops. Good, awesome, got the ball rolling, awesome. Mark 2, algae, because algae had ludicrously high lipid content. Lipid, if you look into chemistry, it's almost like crude. So we looked into that. But there was Mark 3, which somehow people forgot, seaweed. Why? Seaweed, we have surface area. Like if you need 50,000 square kilometers to generate enough fuel for, let's say, aviation. Aviation cannot work on anything else. You just do that. Can you do that on land? No. No, just even though surface area wise you might find the land, you can't find enough land that is free, not from crops. So, and again, you want land for other things also, like airports, industry, things of that nature. You need a lot of land for a lot of other things. Sea, it's free. Sea is free. This is like the green zone is India's economic zone where we do not have to talk someone else. So we can, like, if it takes 100,000 square kilometer, like, we got this, bro. We got this. Like, you will not even see it from far away. Like, you're like, bro, it's just a dark green patch. It's not that big of a deal. And how do you convert that basically green goo into something useful? Well, hydrothermal liquefaction, known technology. If you ever wondered what do chemists study, especially hydrocarbon chemists, ta-da! And it gives you biocrude. What does that mean? That simply means you send that biocrude to normal, basically crude oil refinery, you get almost the same output. Like Mobil, Greece, naphtha, and all that jazz. You do not have to worry about it. We know this. Like, this is a known thing. This is something chemistry level people do. This is what you do in college level project. It's a known thing. It's not like, whoa, how this complex. No, it's a dumb project. We know this, how to do this. And again, here's the sad reality of it. The original project that started people to, like, go from Mark 1 to Mark 2 happened on Aquatic Species Program. This was triggered by US Department of Energy and National Renewable Energy Labs, NREL, in 1978. Like, wait a minute, that sounds long ago. Well, yes, that time America got bitch slapped by what we call oil embargo. So a project was started to create alternatives. They ran through everything that you can think of, everything. Outcome was the only same thing. It's like crops will not work. Crops have like too little lipid content to be viable. As in, like, you can do it. It's just that our consumption is so high, it's stupid. So they looked through it. Outcome was it has to be either algae or seaweed. And they started to really dive deep into algae and seaweed. And outcome was seaweed is scalable. Algae requires you way too much infrastructure and bonkers amount of fresh water, upwards of 800 liters per liter of fuel. That is just no. That's just like, no, you will drain river reservoirs in day one if you try to do that. So, and this project did not take too long to come to result. 1978 project started, 1996 they closed it. Now, like, why did they close in 1996? Someone in OPEC was smart and they're like, okay, if America actually started to do this, because be mindful, that time they were like, hey, price will be 2x if we start to do it today. And again, let's say they were optimistic. Let's say the output would have been 3x. But again, if they kept working on it, it would have gone through the same phase as the solar industry. Solar panels were bonkersly expensive, but more we used it, the more better economy of scale started to happen, the more research and development happened. Ta-da! Now it's cheap. Now it's dirt cheap. Same thing would have happened to them. Because again, surface area is there. Sun is untaxable. And it does not even require that much minerals. So it would have easily worked. But again, they collapsed the oil price. Now everybody, oh, it's going to be expensive. Of course it's going to be expensive. You start an expensive thing, then it becomes cheap. It's almost like people don't even remember it took $8,000 for first Motorola smart phone, so brick phone. It's almost forget, like, first flights were like a luxury thing, like ultra luxury. Like, you had to be local millionaires to afford the original Model T. It wasn't like, oh, everybody had Model T. No. It was uber expensive, people. So that's how it happens. Like, you start with and then you scale it up. We know this, like, every time, but everybody is like, no, but it's a chicken and egg problem. It's like government does not want to do power purchase agreement. Even though they did for nuclear, they don't want to do this because it will actually solve the problem. Oh, it also does one other thing. You can keep making biocrude and just dump it back into the ground. It will stay there. How do we know? It was there. So land fuel, again, complete magical bullshit that people want to believe in, which again, we know scientifically, paper-wise, everybody knows it. And what is the comparison difference between land and sea? It's 5x, meaning if you're doing just super unoptimized yield, that should be 5x the land. Basically 1 square kilometer, it would be on sea would be equal to 5 square kilometer on land. And if you do it well, you're looking at least 10, at least 10. So that's the land fuel magical bullshit. Now let's come to reality of it. Well, here's the deal. As of now, given the fact of Earth, as in Earth has atmosphere, Earth has this much gravity, we do not have any other idea or any tool that can even replace hydrocarbon. And now people will smoke some brain damage and will say, what if we do basically nuclear? Here's the deal. Nuclear does not work. We have been trying it from 1950s. Why it does not work? Well, it has 4 emission patterns. Alpha, not an issue. Beta, not an issue. Gamma, minor inconvenience but manageable. Neutron, yeah, it's unstoppable. To give you a concept, can you make a nuclear reactor that is this size? Yes, people have it. Like, a children built it, like a fire scout guy built it. Sorry, what they call a school scout or something like that. There is a Guinness Book of World Record. Not desirable, but they did it. What was the problem? Radiation. That's the main issue. Neutron is not charged particle. It does not care. Most of the atom is void space. Neutron can just go through it. And that itself is not a problem. Problem is if it interacts with any atom, either it will make it radioactive in case of water, or it will dump enough energy into it that the atom that it got kabam, basically the nucleus, will dump energy again. As in, that will start to become radioactive. As in, it could give out gamma rays. Neutron hit and your object itself started to dump gamma rays. That's how bad neutron is. And here's the deal, that's fission. Fusion has a neutron damage that makes fission look like a bitch please. So I have no idea, like people are like, oh, fusion will solve our problem. It's like it has more neutron emission. If you need, let's just say 2 meters of concrete to stop neutron from kaputting everything in case of a fission reactor, you need at least three, ludicrously high dense and perfectly crackless to make sure that you're not getting neutron cooked from a fusion reactor. I'm not talking about anything else, just the neutron. Like it's almost like people never paid attention to the CERN documentaries where they're talking like, okay, we have these panels, the panels are getting destroyed because of neutron emission, and we have to have a robot that is made out of ropes and cable, because again, electronics will not work in such a radiation environment. Like a reactor is off. Yeah, neutron made everything radioactive. So yeah, they have to have robots that is just a puppet robot that goes in, collects the basically, and again they have to have mirrors as a periscope, because again the camera has to be outside of the radiation shield. So that's how they're gonna, that's how gonna replace the basically blocks, that tungsten block, and the tungsten blocks start to fall apart. Why? Neutron is going inside, kaputting it. So yeah, nuclear does not work. There are only two people who think nuclear works, scientists and engineers. Why they think they work? Because they never do the calculation. It's like solar is too cheap. Nuclear worked in 1950 because there was no solar. Now solar has such low kilowatt hour cost. It does not make sense. Like flat out, it's just not coming. We have been trying this. Thankfully, nuclear gave us pumped hydro. That's the best output of nuclear technology and weapons technology. But other than that, it's not there. So fundamentally, given the fact of reality of 2025, Earth's atmosphere and our energy demand, there is nothing that can replace hydrocarbon. Just cannot. Like if you're like, okay, what if we have toxic ammonia? It still does not have a power. Like still does not have power. Like we've been there, we've done this. Like this is ancient technology. So outcome is we can do carbon neutral. At least give planet enough time to survive. And people are like, okay, what if that it damages the sea? We're gonna be mining sea surface very soon for your batteries. So yeah, shut up. The alternative is you kaput the whole planet or sacrifice a small square of a sea. Small surface, better. So that is fundamentally, we have to start to go into carbon neutral system. And better design and post-processing cleans the exhaust output. For example, right now I'm working with an engine corporation, dealing with like my CV engine system. Again, not mine, but I'm working in it. So I'm starting to realize like why NOx emission is an issue, right? You want everything to be diesel, but people don't want it because it has poor emission. Why it has poor emission? Because it's a bonkersly high compression. But doesn't bonkersly high compression gives you better yield? Yes. That's why BSFC of a, let's say, Scania 4-stroke engine could be 180 compared to 220 of a best Toyota engine you can get. So much more efficient, but problem is it has much higher temperature. Higher temperature, nitrogen in the environment equals NOx. So how do you solve it? Well, you increase the combustion speed. Basically, you do not want to cool down the temperature, but you want to increase the time, as in like a decrease, sorry to say. So dwell time, that's the term they are using. It's like boo. Instead of this, they want boop. So they want it to happen very quickly. And again, that now is the law in F1 2026 jet igniter. The idea is you ignite the fuel so quickly that the temperature goes high, you get more energy out of it, awesome. But it dwell time goes so low, like instead of microseconds, it goes to nanosecond. Like the pulse is so quick that nitrogen cannot react. It almost eliminates it. And that's the dream that we call constant volume combustion. Once you can achieve that, NOx emission goes almost kaput, almost zero. So we can have an engine, diesel engine even, that has almost no emissions. And again, we are really reaching towards it. Right now, the diesel engines we have, the emissions that they have output-wise, it's like unimaginable by 1920s standard, but we have it. And again, the next generations of igniter systems should allow us to get even better. So fundamentally, we can, and again, we have post-processing like putting ammonia in it to clean out all the other things. It is doable. And people are like, no, but I want completely clean. Do public transport. So fundamentally, better designs and better post-processing will allow us to have clean exhaust. And again, same is happening with jet engine also. Jet engine had used to have like very naughty NOx emissions. Now they have made it surprisingly clean. Like again, not clean, but like surprisingly clean. And again, if you're like, okay, but I want 100%, don't fly, do video call. So there will be some point, and we have to accept incremental progress. People who want to, I want magical, like I want an engine that has zero exhaust, somehow forgetting that hydrogen will also create NOx. Yeah, we have to accept incremental progress or we all die. The end. There is nothing else other than that. And magical bullshit. Again, this is the whole point. How the heck humanity keep fell for hydrogen? It's like, bro, hydrogen has 120 megajoule per kilogram. It's 3 times the more power dense. No, it's not. Why? That's kilogram. And if you ever looked at periodic table, hydrogen is the lightest element. So you have to carry the damn thing. How the heck you carry? Carry it in liters. The moment you compare in liter, oh, this is where diesel is and this is where liquid hydrogen is. Go down to 4, that is 700 bar of hydrogen. Go down to even more realistic, one tank would not be stupid expensive, 350 bars. That's like around 2.5. Just use battery. Just use battery at that point. So fundamentally, that's why we and again, this is same. It will remain the same. It will never change. It's law of physics. Of course, we can refine that system and we're like, okay, it's actually 32.3795. That can happen, but it won't go from 30 to 50 or 60 or even 20. That will not happen. So that's the whole thing. If we accept incremental change, we can save it. That's why I'm like so mad about people who are like, oh, series hybrid will not solve it. So because our engines are not getting efficient. Engine efficiency peaked at 1990s. After that, power band has been expanding. That's why we are working so hard for valve timing and this system and that system. Everything is working to increase the power band, not efficiency. We have never ever actually enjoyed engine at peak efficiency. You'd be shocked how efficient your current engine is if you just float it. Like, bro, just run a generator at fixed load, fixed RPM, fixed torque loading, done. You'd be shocked how much energy we have. And again, that will also give time for electrical drivetrain to solve. Everything to be sorted. And again, instead of having stupid batteries of like 80 unit battery, what if your battery is only 15? And again, that also gives you the ability to replace the battery as a component rather than, oh, it's just a battery with wheels. Lot of problems. And again, it's like we need 700-kilometer range. No, only 10% of people need that kind of range per day. They will still use fuel, but everybody else will remove petrol. Diesel will reduce by 10 to 20%. And over time, once we actually start to have battery that has better packaging, better charging infrastructure, better everything, naturally grown systems, ta-da! And again, or you might as well not even do that, just have seaweed biofuel. So inaction and ignorance will waste vital time. So there are people who are like, no, I'll not do anything simply because there is no magical solution. Like, oh, I want nothing coming out of cars. It's like, yeah, the only way to do that is switch to public transport. Ignorance, again, people who do not know this graph, even though it's in every school book, it will be painful. And what does it mean, basically, vital time? Well, assume our ppm of CO2 starts to reach 600. 700, you will reach a point where farmers will start to scream, where it's like, bro, we are dumping bonkers amount of water on our crops and they are still burning. The moment that happens, planet has crossed what we classify as cascade failure. Cascade failure meaning now it cannot be saved. Good luck. Enjoy your magic bullshit if that happens. So, and again, this is hydrogen jet TY155. We've done this. We know this. And again, I'm hearing some good news that Europe finally may not be smoking cocaine, and they're like, okay, let's remove the ban from hydrocarbon in 2050. And again, you can see that, like, this is Airbus A380. If there has 4 engine, and again, many times these aircraft are used for engine testing, they remove one of the engines and put experimental engine there. Logical, sound. Why they have a passport engine? Yeah, that's the engine name, passport. And a tail, 5th engine. Why the heck there is a 5th engine? Because if they feed hydrogen into the main engine was like, done. It will not even spool up properly. It will like, bro, it's a A380 has like 3 axial system, 3 coaxial compressor and turbine setup. Yeah, by the time it spools up, fuel tank would be gone. So that's the reality of it. Like, we can keep searching for magical bullshit, and we can keep staying in inaction. We can keep staying in ignorance, and we all die. So that's the reality of it. If either we accept incremental progress or we all die. There is no other option. And again, keep listening to farmers. The moment they start to say that we are burning water and still not able to save our crops, as in like burning water, as in like you're pouring bonkers amount of it and still not able to save crops, we reached a cascade failure. So this was my presentation on basically the core problem of humanity as of now. Seaweed biofuel versus magical bullshit. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.